everyone for attending today's Cloud Security Assessment webinar. Today, our Cloud Practice Manager, Joe Goldberg, will be presenting. And for those of you not familiar with CCSI, we have been in business since 1974. Our core competencies consist of infrastructure, incorporates data center, IPT, wireless, disaster recovery, video surveillance, and access control. Security, remote workforce vulnerabilities, real-time breach detection, risk assessments, pen and vulnerability testing, DDoS solutions, secure mail, and endpoint protection. And cloud, what we'll be discussing today, migration, backup, disaster recovery, cost containment, and cloud security are some of the things that we do under our practice. We also offer 24/7 application monitoring solutions, and we are a managed service provider and a managed security provider. And we also provide customized SLAs around hardware maintenance offerings. So really, for any questions on today's call, please place them in our WebEx chat. And I'd like to take this opportunity and introduce you to Joe Goldberg of CCSI.
Thanks a lot, Joe. I really appreciate it. Today, we're going to be doing a brief overview of cloud security. And, you know, most people have the concept that either extreme, you move to the cloud and everything is perfectly secure because AWS or Microsoft will take care of it, or there is no possible way to secure the cloud. And obviously neither of those are true. Securing the cloud is just like securing anything on-prem. Just the attack surface looks just a little bit different. So overall, why is security so hard, especially in the cloud? There is a lack of visibility. The cloud offers challenges to visibility that don't exist on-prem, especially when you don't own the networking hardware and the underlying server hardware. And until recently, there was a low degree of automation. And even today, with the automation tools that are available, many people aren't taking advantage of them to ensure that the human factor in security is not, you know, biting you. Before the cloud and the advent of DevOps, people could either move fast or stay secure. So if you wanted to get your product to market quickly and quickly iterate your market, very often security was sacrificed. But in the days today with the cloud where everything is internet facing, that's not a possibility. You have to be able to move fast and stay secure at the same time. And this poses challenges for a lot of organizations that you know come from a more traditional waterfall development mindset. Moving to the cloud offers you a shared responsibility model. I stole this from Amazon, but this is true of all the cloud providers, whether it's Amazon, Microsoft, Google, Oracle. The cloud provider is responsible for securing the facilities, all the physical security. They have armed guards, they have, you know, iron fences, they have multiple layers of physical security beyond what you would have in your traditional, you know, corporate data center. They're responsible for the compute infrastructure, all the servers, all the cabling. They're responsible for the storage infrastructure, the spinning disks, the SSDs, all that stuff. And the network infrastructure, the switches, routers, physical firewalls, whatever else they're using in their infrastructure. And they're usually responsible for the virtualization layer. So in Amazon's case, that's EC2. It's a virtual server in Microsoft. So they're responsible for the software that is actually creating the infrastructure as a service workstations that people are using, or servers. They have to harden their service endpoints, and most cloud providers offer very rich IAM capabilities, which is, you know, user management, rights management. In AWS and Google, they call it IAM. In Microsoft, it's Active Directory. They both get you to the same place. Most cloud providers have an extensive set of security services in AWS. They have guard duty, Macy, and other services to help you secure your environment to ensure that everything that's running in it is what you want running in it, and that people are not penetrating from the outside. And they have extensive assurance programs. Things that you're responsible for as the user is the network configuration. If you leave your machine all ports open, you're going to get owned. You still need to be able to secure your machine. You need to be able to set up security groups. You need to patch the operating systems on your servers. You need to control the firewalls in your servers. You need to harden the operating systems in your servers. You have to make sure the applications you're running are secure. Proper service configuration, account management, authorization, normal data security. You need to ensure that your data is encrypted. And the best thing to do is really to automate as much of that as possible. And then putting both of those together, you can create an extremely secure and compliant system, much more so than you could on-prem. CISOs today overall, though, are concerned. They have three major challenges, and this is from a Gartner 2019 report. They're concerned about talent shortages in DevOps and security, vendor and tool alert overload. Every time you add a tool, you get more alerts, and after a while, you get alert fatigue, and people stop responding to the 2 a.m. pages. So you need to ensure that what you're sending out is intelligent, it's actionable, and it really is an emergency. And cut down on the false positives, and cut down on, don't send out stuff that's informational at 2 o'clock in the morning, because you're just going to burn your people out. And how do they keep pace with the rate of innovation? This industry keeps moving faster and faster and faster. It was initially virtualization, then everybody started moving to the cloud. Now it's containerization and microservices and function as a service or platform as a service. So CISOs are having a hard time keeping up with it and keeping their staff up to date on all of these innovations and how to secure them. So really what this means is that security in the cloud is not as much a technological problem, but it's an operational problem. The technologies exist today to secure pretty much anything in the cloud, and a lot of them are the same technologies you use on-prem. But you need to, because of the faster pace and the different attack surface, you need to ensure that your operations are running as airtight and repeatable as possible. To help you with this are the syscontrols. We've been running another series of webinars on the foundations of security, and Matt Pascucci, our cybersecurity practice manager, had a whole session on the NIST and syscontrols. Amazon and Google have standardized on the syscontrols. Everything that they report on is based off of these controls. Microsoft a little bit less so. They're a little bit more on the NIST side, but basically they get you to the same place. The CIS controls are really just another layer on top of the NIST foundation. So you're not going to go wrong. So kind of at a very high level, I'm not going to dive into it as much as Matt did, but on a very high level, if you want to look at the syscontrols and compare it to a medieval castle, which has multiple layers of security. You have your basic security, which would be like your gatehouse defenses and your wall and watchtowers. The first line of people that are going to, scream at you if you try to break in. You have your foundational, which is really the meat and potatoes after you realize you're being engaged. You have archery, projectiles, maybe you're dumping oil over the wall, your drawbridge and your moat, and your dogs, your hound husbandry. And then internally, to keep it all going, you have your blacksmith, which is keeping all your tools sharp, everything's running, and you're constantly training your troops, drills and melees and all sorts of stuff like that. Looking at it in the real world, not as a medieval castle, the CIS controls are broken into three basic groups: basic, foundational, and organizational. The basic ones are it's common sense: inventory control and hardware assets. Know what you have in your environment. Inventory and control of your software assets. Know what you're running in your environment. You should be doing continuous vulnerability management so you understand where your risks are, where you're vulnerable, what software vulnerabilities, what holes you have in your infrastructure. You can't plug up everything, but the holes that you have, you can at least try to secure and be aware of and limit the blast radius. Controlled use of administrative privileges, secure configuration for hardware and software, and maintenance, monitoring, and analysis of audit logs. That's going to be like your canary in the coal mine as you see monitoring and other stuff sort of, take a turn to the unusual. Foundational, you want to protect your email, your browsers, you have malware detection, you want to limit the ports and protocols that are open, data recovery, secure configuration, data protection, boundary defenses. These are all common sense. And then organizationally, you want to implement security awareness and training programs. Make sure, if somebody's getting an email that says that their, cousin in Nigeria wants to give them $20 million and all they have to do is click the link, perhaps they shouldn't click the link. And applications, software security, incident response, penetration testing, and red team exercises. You should make sure that the controls you have in place and the systems you have in place are actually working, and that when people start to make progress in your infrastructure, you have the organizational wherewithal to take control of the situation. In AWS, they also have what they call the 5 pillars of the AWS well-architected framework. Again, this is an AWS thing, but it does carry through to all cloud providers. The names of the services are different. It's a good framework to follow, and it is also based off the CIS framework. So this is kind of like a bolt-on top of that. That's more cloud specific. There are 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. Operational excellence is the pillar you want to keep everything running. Everything should be up and running and providing business value. You should be continually improving your procedures. As something goes wrong, you should have a post-mortem. What went wrong? What can we do to prevent it from going wrong again? And automate as much as you can so that you're going to be consistently getting the same results. Security, which is what we've been talking about, keep all of your systems and your data as secure as possible. Reliability, keep it up and running, and in case of a failure, be able to recover quickly. Have a business continuity plan, all sorts of different recovery planning options based off of different sorts of disasters that could befall you. Performance efficiency is keep everything running and performing as needed, but also in the cloud, since you're paying for what you're using, you want to make sure that you're not overpaying and oversubscribing. Like if you buy a server that you're using on-prem, you're going to buy it and say, I need a server that's X big, but I'm going to buy it 3 times the size so it'll be good for the next 3 or 4 years. In the cloud, you don't do that. You want to run your servers as close to the breaking point as possible and be able to automatically scale up and scale back down to maximize your cost efficiency, which comes to the last pillar, which is cost optimization. You need to understand what you're spending in the cloud and make sure you're maximizing the amount of services you can get for the amount of money that you're spending. This brings us to the CCSI Cloud Security Audit. CCSI can do a cloud security audit for you in Google, Azure, or AWS. And it is a report that will, based off of the CIS and well-architected framework, will generate a report that will show you pretty much any gaps that you may have. We run it once. We work with you to figure out the results of the report, and then try to help you mitigate everything that we can, and then run it again and see if it's clean. But CCSI's whole philosophy is that we solve problems, and we're not just pitching technology. Like we don't just come to you and say, buy this product, buy that product. we want to fix the problem at hand. If there's a product that helps do that, then great. If it's an operational thing, we'll help you with that as well. And the top problems for CISOs in the cloud era are identity and access management, an ever-evolving network perimeter. There's mobile, SaaS, now platform or function as a service, containerization, Kubernetes, all sorts of stuff. It's coming fast and furious. And there's still compliance requirements. Just because you've moved to the cloud, and yes, all the cloud providers are SOC 2, Type 2, ISO certified. Most of them have FedRAMP and every kind of certification under the sun. You as the user still have to make sure that the environment you run in their environment is compliant. And hybrid cloud visibility, you need to be able to see what's going on and how your systems are performing, even when they cross from multiple cloud providers or from a private cloud, whether in a colo facility or your own data center, and to the public cloud. And you need to have security policy management, so to ensure that the security policies that you have on-prem are being translated accurately into the cloud, so that you know where what your situation is at all times. Part of our cloud security audit is we'll do infrastructure discovery. We'll generate a graph basically of your infrastructure and who can talk to who type graphic. We'll give you a summary of the findings. These are all the different services within AWS, and the ones that are gray are services that are not being used. Red means there's something critical wrong. Yellow means it's caution, and green means that everything was fine. And then we'll give you a in-depth look into it. So we'll tell you all the tests that passed, what we checked for, and then what failed. And then we'll give the report, we'll tell you what you can do to help mitigate the problem. And we'll actually go over all of this with you in a post-mortem conversation after the report is generated. The CCSI has a lot of other cloud security services as well. We have disaster recovery as a service and backup as a service. I know you might not consider them security services, but they really are the last ditch resort after you get hit with ransomware. If you get hit with ransomware, if it happens to make it through your email scanning, your virus scanning, your endpoint protection, all that stuff, and happens to get into your infrastructure, if you can fail over quickly into a disaster recovery scenario or recover quickly from backup, then you've not only saved yourself a lot of money, but you've also cut down the risk of exposure to the public, which could be bad for your organization's reputation. We also offer visibility as a service. It's a full service platform that has metrics, logging, tracing. We work in the cloud through Kubernetes, Docker, whatever you're looking for to monitor. Pretty much if it has an IP address, we can talk to it, or if it has an API, we can grab statistics from it. And we can monitor in very short frequencies rather than old school traditional monitoring, which would look at something every 5 minutes. We can go down to every 10 or 15 seconds, which is important in a containerized world where a container may exist for only 30 seconds or 45 seconds. You want to know it existed. You want to know that it performed correctly and that it terminated properly. And of course, we can alert on this, and these alerts can go directly to you, or they can be fed into our 24/7 NOC and SOC. And the talented folks in there can either hunt you down to let you know there's a problem, or they can actually work off of a runbook and start to try to resolve the problem as they're notifying you. We do that for a lot of customers so that, we hit the ground running. By the time the customer gets on the phone, we're like, yeah, it's already fixed. We're good. We do have microservices security. This is kind of the newest challenge in cloud native. I'm running a large Kubernetes environment. I need to understand what containers do I have, what pods are they running in, what namespaces, who are they talking to, on what ports, and are these containers safe? scan the container before it gets pushed into production to ensure that nobody has inserted malware into it, or any sort of services that you are not aware of. Ensure that the containers are speaking to each other as expected and not doing anything unusual. And ensure that your environment is stable and you're not giving out excessive privileges, either user-based or communications-based. And cloud and security governance, cloud cost and security governance. Once you're in the cloud, it's important that you be able to manage your costs and understand where your costs are. Your CFO is not going to be happy if your monthly spend goes from $3,000 a month one month to $30,000 a month the next month. So it's critical that you have that under control. And you also need to continually look at your cloud environment and make sure you're maintaining the security compliance that you need to for your specific industry. Like if you're HIPAA compliant, you want to make sure that somebody just launched 10 new servers in your environment and they've completely blown up your HIPAA compliance. You want to be warned of that in near real time rather than waiting 6 months for your next audit and being like, oh my God, how many health records leaked out of here? I guess I will stop here and see if anybody has any questions.
Hey, Joe, I had actually a couple questions, 2 questions come in.
Excellent.
One is specific to the timeline associated with the audit you mentioned. What would be audit timeline expectations?
We usually run the audit for about 2 weeks. It speaks to the APIs in the customer's cloud environment. So we'll run it for 2 weeks to get a good baseline. And it takes us about a week to generate the report and put together all of the findings. We'll then have a call with the customer to review the report and hand it off to them, and then help them put together a plan to mitigate whatever they need to mitigate, and go over. Sometimes there are things you know they're wrong, or it could be problematic, but it's either a risk you're willing to take, or a risk you have to take, or based on your environment, it's not really a risk for your particular environment. So we can make sure on the second running of the scan that won't be triggered again. And then we'll work with them as needed to resolve the issues, and then we'll run again for another 2 weeks, generate the report, and hopefully they get a nice clean report that they can hand off to auditors or anybody that's looking to question, or management, and say, look, our environment really is following best practices. And it's one of the rungs of testing your environment, kind of like a penetration test, a risk assessment, stuff like that. It's just another layer in the onion.
And Joe, the other question was around resources, specifically, what type or how many resources are needed to participate from the end user side?
In a cloud security audit?
Correct.
I would think that organizations with 10 or more resources, I think once you're under 10, it's, unless they're giant resources and you have major compliance requirements, it's probably not necessary. But once you start crossing beyond 10 or 15 resources, and we've done cloud security audits for people with thousands of resources, then it starts to become a little bit, less manageable. You have multiple VPCs across multiple regions, and, maybe tens or hundreds of servers spread across, and multiple people touching the environment. Then it becomes a challenge.
Thank you, Joe. I'll just pause for a couple seconds in case anyone else has any other questions. Well, I'd like to say thank you for your time today. Your account manager will be following up to discuss next steps. Thank you.